Hello and welcome to this video that's going to go through some titration questions and goes step by step how to solve them. So the first question we have is actually quite a difficult question. We're given 25 centimeters cubed of 0.2 mole per decimeter cubed of barium hydroxide solution reacted with 22.8 centimeters cubed of hydrochloric acid. Calculate the concentration of the hydrochloric acid in moles per decimeter cubed, giving your answer to three significant figures. As usual, please try the question and get as far as you can before listening to the solution. So let's go through the question. So the first thing we need to know is the formulas that we're going to use. So the first thing that we have is the concentration, and the concentration formula is given as moles divided by volume. So this is the key equation here. So concentration equals moles divided by volume. Now the key thing about the volume, and we can see it here, is that the volume needs to be in decimeters cubed. So it's really important that you make sure that your volumes that you're using are converted to decimeter cubed. So the first thing that we need to do is find moles, because we don't have much information. We know the volume of hydrochloric acid, but we actually want to find the concentration. So the thing that we're missing from our equation is the moles. So the end goal of this part of the calculation is basically to find the moles of hydrochloric acid. Once you found the moles of hydrochloric acid, you can plug all your values into the equation. So first of all, we have to look at the barium hydroxide solution, and we can calculate the number of moles of barium hydroxide. The reason why is because we have everything we need. We know the volume is equal to 25 centimeters cubed. Now we know that this is going to be a problem because our concentration demands that we have decimeters cubed, and we know that the concentration of barium hydroxide, so let me just put it up here so we remember what this is for, is equal to 0.2 moles per decimeter cubed. So what we need to do with our volume, this is the issue in this question, is to convert that into decimeters cubed. And to do that, we divide it by 1,000. So 25 divided by 1,000 is equal to the volume in decimeters cubed. So from here, we can say that, if we write the new volume down, it's 0.025 decimeter cubed. From here, we can find the moles, because the moles is given by rearranging this equation. So mole is equal to the concentration times the volume. So in this case, it's equal to 0.2 times 0.025. Plugging that in gives us 0.005 moles. From here, we know the molar ratio for barium to hydrochloric acid is 1 to 2. So it's a 1 to 2 molar ratio, therefore the moles of HCl is equal to 2 times 0.005, which is equal to 0.01 moles. And from here, we've now nearly finished the question. Our goal is to find the concentration. So if we go across and we think about our HCl of the moles is equal to 0.01, and the volume is equal to 22.8 centimeters cubed. Now obviously we're going to have to deal with this centimeters cubed because again we want our concentration in decimeters cubed. So we do 22.8 divided by 1,000, which is equal to 0.0228. Now we can find our concentration. So plug this in. So the moles 0.01, divide that by 0.0228, and that gives us our concentration of 0.439 moles per decimeter cubed. And that's it. And that's your answer. So now we move on to number 2, and again, please try this before listening to the answers. We're given 22.5 centimeters cubed of sodium hydroxide solution reacts with 25 centimeters cubed of 0.1 mole per decimeter cubed of hydrochloric acid. Can you calculate the concentration of sodium hydroxide in moles per decimeter cubed, giving your answer to 3 significant figures? Okay, so in this situation, we are going to now calculate. So again, what we're looking for, so we've got sodium hydroxide, so that's this one. So what do we know so far? So NaOH. So the volume here is equal to 22.5 centimeters cubed, which again we want to convert. We always want to convert, or 99 times out of 100, want to convert to decimeters cubed. So converting this into decimeters cubed, you can do this now, you can do this when you need it, it doesn't matter. You're going to need to do it at some point. So that's 0.0225. And this, write down what you know immediately, and it will help you build up the question and what you need to do. HCl is the next one. So we're given, again, the volume is equal to 25 centimeters cubed, and this is equal to 25 over 1,000 in decimeters cubed. So 25 over 1,000 is equal to 0.025 decimeters cubed, and we're given that the concentration, so C, is equal to 0.1 moles per decimeter cubed. So then from here we want to find the concentration. Well, we're going to use the concentration formula. So concentration is equal to moles divided by volume. If you ever forget this, just look at the units. It gives you the clue here. It's moles, which is mole, divided by dm cubed. So it will always give you the unit, so that's how you can remember the concentration formula. So the concentration here, what do we want to find? So we want to find the moles here. So we're going to do concentration times volume, which equals moles. And then we're going to plug in our values. So it's 0.1 times 0.025, and that's equal to the number of moles, which is 0.0025. From here, we then find, so this is the number of moles of hydrochloric acid. So then we can look at the molar ratio of hydrochloric acid to sodium hydroxide. So it's a 1-to-1 ratio. Therefore, the moles of sodium hydroxide are also equal to 0.0025. And then from here, we can find the concentration is equal to the moles, which is 0.0025, divided by the volume, which is 0.0225. Plugging that into your calculator will give you an answer of 0.111 moles per decimeter cubed. And that's your final answer to this one. If we move forward and find part B, calculate the concentration of sodium hydroxide solution in grams per decimeter cubed. So this, now we're changing the units. So it's really important that we think about what's going on. So we know that the concentration of sodium hydroxide in grams is going to be as follows. So it's going to be equal to, if we know the moles, is equal to 0. Oh, hang on, apologies. So here we can do a conversion here from moles to grams per decimeter cube, and the way that we can find this one is that we find the concentration in moles per decimeter cubed, and we times that forward by the mR. So this gives you the concentration in grams per decimeter cubed. So the way that we do this one, again, the concentration we're given, 0.111, and then we look at the MR of sodium. So I've written 40 here. actually should be equal to BMR. And then from here we just plug it in, so that's going to be equal to times 23 plus 16 plus 1, which of course is 0.111 times 40, which gives us our result 4.44 grams per decimeter cubed. Okay, pause the video and try the next question, which is what volume of 0.15 moles per decimeter cubed of rubidium hydroxide reacts with 25 centimeters cubed of 0.24 moles per decimeter cubed of nitric acid, giving you answer to 3 significant figures. So this one, again, we start off, you might as well always just start off looking at your reactants nitric acid, because you know the volume and you know the concentration. And basically you're going to find the moles again. So again, with these ones, it's always regularly just finding moles. It's a very common theme. So the volume, 25 centimeters cubed, which is equal to 0.025 decimeters cubed, and then you would say that the concentration is equal to 0.24 moles per decimeter cubed. So the moles is equal to volume times concentration, which is equal to 0.025 times 0.24, which is equal to 0.006 moles. So that gives you the moles of nitric acid. And again, it's a very similar one as before. We look at the ratio, so it's a 1-to-1 ratio between nitric acid and rubidium hydroxide. So therefore, the moles of rubidium hydroxide, so RbOH, is equal to 0.006. From here, we can then, once find the volume, we know the concentration is 0.15. So from here, we just use the equation. So we know the concentration is moles over volume, so volume is equal to moles divided by concentration, so it's 0.06 divided by the concentration, which is 0.15, and plugging that into your calculator will give you a result, which is 0.04 decimeter cubed. And that gives you your final answer to question 3. Okay, moving on to question 4. Question 4, so again, try the question, 25 centimeters cubed of 0.2 moles per decimeter cubed of sodium hydroxide solution, react to 28.7 centimeters cubed of sulfuric acid, calculate the concentration of sulfuric acid in moles per decimeter cubed. So pause the video, try the question, and then we'll pause to see the answer. So here again, sodium hydroxide reacts with sulfuric acid. We want to find the sulfuric acid concentration. So we always start with what we know, which is the sodium hydroxide. So it's NaOH. We know the volume is equal to 25 centimeters cubed. So again, we do our typical step, divide that by 1,000. So 25 over 1,000, which gives you 0.025 decimeter cubed. We know the concentration is equal to 0.2 moles per decimeter cubed, and we want to find what the moles are. So moles equals C times V, which is equal to 0.2 times 0.025, and that gives you an answer of 0.005 moles. From here, the next step is to look at the molar ratio. So we're trying to find sulfuric acid. So sulfuric acid in this situation is going to be H2SO4. So it's a 2-to-1 ratio. So 2 moles of NaOH to 1 mole of H2SO4. So in this situation, it's going to be 0.05 divided by 2, which is equal to 0.0025 moles. So that's the number of moles of H2SO4, and then we go through. So we know mole of H2SO4 is equal to 0.0025. We know the concentration is equal to 28.7 centimeters cubed, which is actually equal to 28.7 divided by 1,000, because we're going to convert this to decimeters cubed, so it's equal to 0.0287. From here, we just plug in our numbers, which is equal to, so again, we're trying to find the, so here's a small mistake. So it's not concentration, we've already got concentration. We're trying to find the concentration, it's the volume. So the concentration is equal to moles over volume, which is 0.0025 divided by 0.0287, which plugs into our, if we put that in, we get 0.0871 moles per decimeter cubed. Okay, let's move forward to question 5. Calculate the concentration of ethanolic acid in moles per decimeter cubed, giving your answer to 3 significant figures. So, in this situation, again, very similar, same method all the way through. Start off with what you know, sodium hydroxide, NaOH. Also pause the video if you haven't already to try the question. NaOH. So the first thing we know is the volume, which is 25 centimeters cubed, which is equal to 25 over 1,000, which is equal to 0.025 decimeters cubed. We know the concentration, 0.15 moles per decimeter cubed. So therefore we know that the moles is equal to concentration times volume, and then we're going to plug that in. So it's 0.15 times 0.025, which gives us 0.005 moles. Then we want to find the concentration, oh no, my apologies, not this one. Looking at the wrong answers. So the answer is 0.00375 moles. Then we look at the next part, which is the ethanolic acid. So this is CH3COOH. So here 30 centimeters cubed, so volume is 30 centimeters cubed, which is 30 divided by 1,000 to get us to decimeters cubed, which is equal to 0.0303 decimeter cubed. And then from here we're going to plug in our molar ratio is 1 to 1. So therefore the moles of CH3COOH is 0.00375, and then the concentration is equal to moles over volume, so that's equal to 0.00375 divided by 0.0303. Plugging that into our answer, it's equal to 0.124 moles per decimeter cubed. Then we move forward and part B, calculate the concentration of ethanolic acid in grams per decimeter cubed. So for this one, we are going to first of all find the MR of ethanolic acid. So ethanolic acid CH3COOH, so it's going to be 2 times 12 plus 2 times 16, that's the carbons, the oxygens, plus 4 times 1. So plugging that into our calculator would be 24 plus 32 plus 4, so we get an MR of 60. And to find the concentration in grams per decimeter cubed, that's equal to the concentration in moles per decimeter cubed times the MR. So in this situation, it's simply going to be 0.124 times 60, which is equal to 7.43 grams per decimeter cubed.